morning, children. Today we are going to learn about the topic arithmetic progression. Before discussing arithmetic progression, first of all we should come to know what the sequence is, what is the progression, what is series. So first one is, what is a sequence? Sequence is an arrangement of numbers arranged in a definite order according to definite rule. So sequence is an arrangement of numbers which are arranged in a definite order according to definite rule is called a sequence. So let us take some examples to understand the sequence, what the sequence is. So first of all, this first example is here. If we take a list of numbers 2, 4, 6, 8 and so on. Take another example here, second one. It is 1, 4, 9, 16 and so on. And let us take another example here. Example number third. It is 2, 3, 5, 7 and dash dash dash. Now another example is example number 4. Here we take, it is 5 or 3, 5, 8, 20 and so on. So let us take these examples one by one. So first list of numbers is here 2, 4, 6 and 8. In this list of numbers 2, 4, 6 and 8, they follow some pattern according to some definite rule. That is, we have a first term here 2, then after that if we add this 2 to the 2, that we get 4, then we get 4, we add 2 to this number 4, we get another number 6 and so on. If we add 2 to this number 6, we get a number 8. So this list of numbers is in a definite order or according to some definite rule. So this sequence, this list of numbers is said to be a sequence. Now second one is 1, 4, 9, 16. Clearly they are the squares of natural numbers. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 and so on. So this follows another mathematical rule here. They are the squares of natural number. Similarly in case third, this is 2, 3, 5, 7. They are all prime numbers. They are all prime numbers. So they are also in a well-defined manner here. They are in the very well-defined arrangements here. 2, 3, 5 and 7 are said to be sequences. Now let us take the fourth one. It is 3, 5, 8, 20 and so on. This list of numbers does not follow any pattern, because if we take this 2, if we add this first term, that is 2 to 2, we get 4, and here we have a first term 3. If we add 3 to 2, we get 5. Then we have second term 5, we add 3, we get 8, and we have, then after that if we add 12 to this 8, we get 20, and we can't predict the next term of this AP. Here in this first one, we have a term 4, 6, 8 and so on, and we can write the next term, and next term will be equals to 10. And in this second one, the first term is 4, first term is 1, second term is 4, third term is 9 and fourth term is here 16, and we can predict it is fifth term, that be equals to 25. So here it is 2 first term, second one is 3 and third one is 5, fourth one is 7, and we can write down the next term as it is 7, then it will be the 11. But in this case, this is 3, 5, 8 and 20. We can't write what is the next term. So this one is not a sequence, because this list of numbers does not form an arrangement in a definite manner, and this we cannot find the next term after 20. So this list of numbers does not form a sequence. First one is a sequence because it is well defined, because it is follow some pattern according to definite rule. Second one is also a sequence, and third one is also a sequence. Now after sequence, what the progression is? Second one is progression. progression. If the terms of a sequence, can be described by an explicit formula, then the sequence is said to be the progression. Means, if the terms of a sequence can be described by an explicit formula, then the sequence is said to be the progression. So let us take for this example progression, let us take the same example 1 here, 2, 4, 6, 8 and so on. So here the numbers in this sequences are said to be the terms. So 2 is the first term, 4 is the second term, 6 is the third term, 8 is the fourth term. And here this one, A1 is here 2. And we can write this 2 as 2 into 1. Similarly 4, A2 second term is equal to here 4, and we can write 4 as 2 into 2. Then second one is 6, third term is here 6, we can write this 6 as 2 into 3. Here we observe a pattern. If we write here A1, this is 2 into 1. Here it is 1, this is here 1. A2 is 2 into 2. Here is 2, this is also equals to here 2. So A3 is equal to 2 into 3, and we can write it as AN. If we take up it to nth term, so AN can be written as like A3 is 2 into 3, A2 is 2 into 2, A1 is 2 into 1. So AN is equal to 2 into n, and we can write it as 2n. So in any sequence, if we describe its nth term, if we are in a position to describe its nth term, then the sequence is said to be a progression. So in this case, an, general term of this one, is equal to 2 into n. So this sequence is also said to be a progression. Now the second example here, second one is here 1, 4, 9, 16 and so on. So here A1 is 1, A1 means first term of this sequence, that is 1, or we can write it as 1 square, this one. And second one is here A2, that equals to 4, we can write it as 2 square, this one. Then A3 is 9 here, so 9 can be written as 3 square. So in this way we can find its nth term, that is an. Here it is A1 1 square, A2 2 square, A3 3 square. We get a pattern here, and in general an is equal to n square, where n is a natural number. So in this sequence 1, 4 and 9, we are able to describe its nth term. So an is equal to n square. Then this sequence is said to be a progression. Now let us take another one, third one. Third one is here, it is 2, then it is 3, then 5, then 7, dash dash dash. So here in this sequence we are not in a position to find its nth term, because there is not some mathematical rule. So its first term is 2, another one is 3, next one is 5, next one is 7. So we are not in a position to describe its nth term. So this one is not a progression. So a sequence is said to be a progression if we are able to describe its nth term, or if we can find explicit formula for finding its nth term. So in this sequence, this is a sequence but not a progression, and this is a sequence as well as a progression, because we can find the nth term of this sequence. Here in this one, this is also a sequence, 2, 4, 6, 8, all are even numbers. So A1 is 2 into 1, and similarly we can find an is equal to 2n. So 2, 4, 6 and 8 is a sequence as well as a progression. Similarly 1, 4, 9, 16 is a progression, and this 2, 3, 5 and 7 is not a progression. So we conclude here that every progression, each progression is a sequence, but each sequence is not a progression. So sequence is said to be sequence is a sequence is not a progression, but every progression is a sequence. Now we have third one, that is what is a series. Now third one is series. Series are the terms of a sequence, connected by positive or negative sign form a series. When the terms of a sequence are connected by positive or negative sign, they form a series. So if we have a sequence 2, 4, 6, 8 and so on, if we connect these terms by a positive sign, then the series is formed. So if it is 2 plus 4 plus 6 plus 8 and so on, is said to be the series. So when a sequence is connected by positive or negative sign, then the sequence form a series. Now after discussing this progression, sequence and series, now the topic is here arithmetic progression, which is our topic, that is arithmetic progression. Now what is the arithmetic progression? An arithmetic progression is a list of numbers. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term. Each term is obtained by adding a fixed number to the preceding except the first term, and this fixed number is called the common difference. So we can write here arithmetic progression as, now the fourth one is here arithmetic progression. So arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term. By adding a fixed number to the preceding term except the first term. And this fixed number is called the common difference, denoted by the letter D. So let us take some examples based on this arithmetic progression. If we take an example of, same example 2, 4, 6, 8 and so on, is a list of number in which first term A is here 2, second term is 4, third term is 6 and fourth term is here given 8. So it is a list of numbers in which each term is obtained by adding a fixed number. So this fixed number is called the common difference. So here we have a first term 2 here, then if we add this first term by plus 2, we get its next term, that is equal to 4, and we have now 4 term. If we add another number, that is 2, to this 4, we get a next number, that is 6. Now if we add this 6 to 2 plus 2, we get another number. So here we are adding this common differences fixed numbers to the preceding terms, we get the terms, next terms of an arithmetic progression. So 2, 4, 6 and 8 is a list of number in which each term is obtained by a fixed number. Here fixed number is positive 2, so this list of number is said to be an arithmetic progression, and this common difference can be negative, positive or 0. So let us take another example here. What is here common difference? Here common difference is denoted by the letter D. It is positive. Common difference is here positive. It is plus 2 everywhere. Now second example is here. If we take second one, we can write it as 20, then 15, then 10, then 5 and so on. Here we have 20. If we subtract 5 from this 20, we get minus 15. We get 15, sorry. If we subtract 5 here, we get 10. If we subtract here 5, we get 5. So in this list of numbers, we have 20, 15, 10, 5. So each term is obtained by subtracting minus 5 to the preceding term. Then this list of numbers is said to be an arithmetic progression where D is negative. Where D is negative. Now the third one is here. If we take an arithmetic progression like 1, 1, 1, 1, dash, dash, dash. So here, yes, this is a list of numbers in which each term is obtained by adding a fixed number. What is here fixed number? Fixed number is here, if we add 0 to 1, we get a next term that is 0. If we add this one to 0, we get another number. So here, common difference is everywhere 0. So we get the next in terms of this one. So this list of numbers is also said to be an arithmetic progression, because if we add 0 to the preceding terms, we get a term. So here, this one is also an arithmetic progression where D is 0. So arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number except the first term. And this fixed number is called the common difference, denoted by the letter D, and this common difference can be positive, negative, or 0. Now, how to find out this common difference? Common difference is actually the difference between two consecutive terms of an AP. So if we have here AP 2, 4, 6, 8 and so on, therefore the common difference D is here A2 minus A1. Preceding term, succeeding term minus preceding term is the common difference, or A3 minus A2 or A4 minus A3 must be same everywhere. Must be same everywhere. When A2 minus A1 means preceding term, succeeding term minus preceding term, A3 minus A2, A4 minus A2 is same everywhere, then the list of numbers is said to be an arithmetic progression. So D can be found by A2 minus A1 or A3 minus A2 or A4 minus A2. Now, how to write the general form of an arithmetic progression? Now the next one is general form of AP. AP means arithmetic progression. We discussed in the definition that a list of numbers in which each term is obtained by adding a fixed number except the first term, then the list of numbers is said to be an arithmetic progression. Let us suppose that the first term of an AP be A and the common difference be D. Then the general form of AP can be written as, if the first term is A, then each term is obtained by adding a fixed number. So here fixed number is common difference, that is D. So if we add D to the preceding term means A, we get second term A plus D is the second term. Now if we add D to this preceding term means A plus D, we get A plus D plus D, that is 2D. The next one is A plus 3D and so on. This one is known as general form of arithmetic progression, where A is the first term and D is the common difference. So A plus D, A plus 2D, A plus 3D is said to be the general form of an arithmetic progression. Now, how to find the general term of an AP? The question is how to find the general term, means nth term of an AP. Here, this is A1. We can write it as A1 is equal to A plus 0d. We can write it as a1 is equal to a plus 0d, or it equals to a plus 1 minus 1 into d. Because 1 minus 1 is 0, so it is 0 here. Now second term is here a2. What is second term here? This is first term in general, and this one is the second term. It is a plus d, or we can write it as a plus 1d. And we can write this as a plus 2 minus 1 into d, because 2 minus 1 is equal to 1 here. Then third one is a3, can be written as a plus, what is third term here? This is first term, that is a1. This is second term, means a2. This is third term, that is a3. It is a plus 2d. That can be written as a plus 3 minus 1 into d. Here we observe a pattern here. So it is a1, it is a plus 1 minus 1 into d. Here it is a2, it is a plus 2 minus 1 into d. Then a3, it is a plus 3 minus 1 into d. Now, if we can proceed it up to nth term, we can write here an is equal to, here it is a3, it is a plus 3 minus 1 into d. It is a2 here, it is a plus 2 minus 1 into d. Then if we write here an, what we can write here? A plus n minus 1 into d. It is a plus n minus 1 into d. And this one is known as general term of an arithmetic progression. So a1 can be written as a plus 1 minus 1 into d again. Then a2, a plus 2 minus 1 into d. a3 is a plus 3 minus 1 into d. And in general, an can be written as a plus n minus 1 into d. And this one is known as general term of an arithmetic progression. Now, general term of an arithmetic progression can be written as general term of AP can be written as an equals to a plus n minus 1 into d. It is a plus n minus 1 into d, where an is known as nth term of this AP, and a is the first term of an AP, and n is the number of terms in an AP, and d is the common difference of an arithmetic progression. So on the basis of these results, now we have to take some questions from your textbook. That is exercise number 5.1. We have a question here. Write first 4 terms of AP when the first term A and the common difference D are given. The question is, write first 4 terms of an AP when the first term A is A and the common difference is D. This is now exercise here. Now we have exercise 5.1. This is a question here. That is, write first 4 terms of an AP whose first term A is given and common difference D is also given. First term is here given, that A equals to 10. It is first part of this question, A equals to 10 and D equals to 10. And we know that when in an AP, if the first term is given and the common difference is given, we can form an arithmetic progression. We can find any term of an AP. So here we have to find the first 4 terms of an AP. Here first term is given, that is A equals to 10. Now what will be the second term, A2? So A2 is equal to A plus 1D, because an is equal to a plus n minus 1 into d, and if it is a2, we can write it as a plus 2 minus 1 into d, and 2 minus 1 into d is equal to 1d. So here it is a, the value of a is 10 plus 1d, the value of d equals to 10, so 1 into 10 is 10. We can write the second term of this AP is equal to 2. Now a3 means third term, we can write it as a plus 2d. a3 is equal to a plus 2d, that equals to a is 10 plus 2 into d is also 10. Then here it is 2 into 10 is 20 plus 10 equals to 30. So the third term of this AP equals to 30. Now a4 is equal to a plus 4d, a plus 3d, that can be written as 10 plus 3 into 10, that equals to 40. So the first four terms of this AP, be 10 is the first term, second term equals to 20, third term equals to 30, and fourth term equals to 40. Now the second part of this question is, we have a given, that is minus 1, and d is 1 by 2. The second part is here, a is equal to, a is minus 1 and d equals to 1 upon 2. So we have first term given here minus 1, and the common difference is given 1 upon 2. So we have to find out the first four terms of this AP. So a1 is given minus 1, we can write a2 is equal to a plus 1d, or we can write a plus d, that equals to a is here minus 1 plus d, or we can write it here, then a is minus 1 plus 1d, 1d is 1 upon 2, so minus 1 plus 1 by 2 is equivalent to minus 1 upon 2 is the second term of this AP. Now the third term is a3, can be written as a plus 2d. So a is given, that equals to minus 1 plus 2 into d, d is equal to 1 by 2. So here we can cancel 2 and 2, we get here plus 1, minus 1 plus 1 is equivalent to 0. So the third term is equal to here 0. Now the fourth term is a4 is equal to a plus 3d. So a is given minus 1 plus 3 into d is 1 upon 2. It is 1 by 2. So we can write it as minus 1 plus 3 by 2. It is minus 1 plus 3 divided by 2. After simplification, we get 2 into minus 1 is minus 2. Minus 2 plus 3 is 1 by 2. That equals to 1 upon 2. So a2 is here minus 1 by 2. a3 is 0 and a4 is 1 upon 2. Now the next question is which of the following are APs, and if they form an AP, find the common difference and write 3 more terms. First of all, we have to check that the given list of numbers form an AP. If they form an AP, then we can find their common differences and next 3 more terms. So the question is, which of the following are APs? First one is, the first part is here 2, 4, 8 and 16 dash dash dash. We have to check that the given list of numbers form an arithmetic progression or not. We know that a list of a number is said to be an arithmetic progression if the common difference between the terms is same everywhere. So first of all, we check the common differences here. So what is a2 minus a1? Second term is here 4. So 4. First term is here 2. 4 minus 2 is equivalent to 2. Then a3 minus a2. Succeeding term minus preceding term. a3 is here 8 minus a2 is 4. That equals to 4. So therefore A2 minus A1 is not equal to A3 minus A2. So this given list of numbers does not form an arithmetic progression. So A2 minus A1 is not equal to A3 minus A2. So the given list of numbers does not form an arithmetic progression, because the common difference is not same everywhere. Now the second part is here. It is 2. The second part here is 2, 5 by 2, 3 and 7 by 2. 3 and 7 by 2. Dash, dash, dash. Is a list of numbers. So first of all, what is A2 minus A1 here? A2 minus A1 means succeeding term minus preceding term. It is 5 by 2 minus 2. So when we multiple 2 into 2 is 4, and 5 minus 4 we can write it as 1 upon 2 is A2 minus A1. Now A3 minus A2 is equal to, the third term is here 3 minus second term is 5 by 2. So we multiply here 2 into 3 is 6, 6 minus 5 is 1, it is also equals to 1 upon 2. The next one is A4 minus A3, that equals to, the fourth term is here 7 by 2, 7 by 2 minus third term is here 3, again simplifying we get 2 into 3 is 6, 7 minus 6 is 1 divided by 2. Here we observe A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A2, both are equals to 1 by 2. So the common difference is same everywhere, that equals to 1 upon 2. Therefore A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3, both are equals to 1 upon 2. So the given list of numbers form an arithmetic progression. Yes, they form an arithmetic progression. Why? Because the common difference is same everywhere. Now if this is a arithmetic progression, then find next 3 more terms. We have A1, we have A2, we have A3, we have A4. Now what we have to find? A5, A6 and A7. Now A5 can be written as A plus 4D. A plus 4D. What is the value of A? A is first term, it is 2, plus 4D, 4 into D is 1 upon 2. When we simplify, we get 2 and 4 cancellation here. It becomes 2, 2 plus 2, that equals to here 4. Then A fifth term of this APB equals to 4. Now A6, sixth term is A plus 5D, that equals to, A is given 2 plus 5 into D is 1 by 2. When we simplify this, we get 9 upon 2. 9 by 2. Now next one is here A7, because we have to find next 3 more terms, that is A5, A6 and A7. It is A plus 6D, that equals to 2 plus 6 into D is 1 upon 2. When you cancel 2 and 3, 6, that becomes 3. 2 plus 3 is equal to 5. So the next 3 more terms are 5, 9 by 2 and 4, 9 by 2 and 5 by 2. So yes, this list of number form an arithmetic progression. Why it is an arithmetic progression? Form an arithmetic progression because the common difference is same everywhere, 1 by 2. And if the given list of number form an arithmetic progression, then according to the question, find the next 3 more terms, that is A5, A6 and A7. Now the next part of the same question is, we have a list of numbers given, that is 3. Next part is of the same question is 3 plus square root of 2 then again 3 plus 2 square root of 2, then 3 plus 3 square root of 2, and so on. There is a given list of numbers. It is 3, 3 plus square root 2, 3 plus 2 times square root 2, and 3 plus 2, 3 times square root 2. First of all, we have to check it, the given list of numbers form an arithmetic progression or not. So here a2 minus a1, what is the second term here? It is 3 plus square root of 2 minus a1, a1 is here 3. So this positive 3 and negative 3 cancel, we get square root of 2. So a2 minus a1 is equal to square root 2. Then a3 minus a2 equals to, the third term is here 3 plus 2 square root of 2, then minus a2. What is a2? It is 3 plus square root of 2. When we simplify this, we get 3 plus 2 square root 2, and we multiple both the terms with the negative, it is minus 3 and minus square root of 2. So this is here positive 3, cancel with the negative 3, then this is 2 times square root 2 minus 1 times square root 2 equals to square root of 2. So a2, 3 minus a2 is also equals to square root of 2. Now a4 minus a3. a4 is here 3 plus 3 square root 2, then minus bracket start, third term is 3 plus 2 square root 2, like this. So we can write it as 3 plus 3 square root of 2, and this is minus 3 and minus 2 square root of 2. Then positive 3 and negative 3 cancel out. This is 3 times square root 2 minus 2 times square root 2 is equal to square root of 2. So here a2 minus a1 is equal to square root 2, a3 minus a2 is also equal to square root of 2, and a4 minus a3 is equal to square root 2. Therefore, a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3. Both are equals to 1 by 3. When the common difference is same everywhere, then the given list of numbers is said to be an AP. Then if the given list of numbers is an AP, then find next 3 more terms. So we have a1 given, a2 given, a3 given, a4 given. Now we have to find out a5 is equal to a plus 4d. We can write it as a. The value of a is here 3 plus 4. What is the value of d? That equals to square root 2 everywhere. So this term is 3 plus 4 square root 2 is the fifth term. Similarly, a6 is equal to a plus 5d. It is a plus 5 square root of 2. Then a7 is equal to a plus 6d. That equals to 3 plus 6 square root of 2. So the next 3 more terms are 3 plus 4 square root 2, 3 plus 5 square root 2, and 3 plus 6 square root of 2. Now the next part is here square root of the same question. It is square root of 2, then square root of 8. Then we have another term of this same is square root of 18 and square root of 32, and so on. Is this list of numbers form an AP? If they form an AP, then find next 3 more terms. So we can simplify this as square root of 2 is square root 2, and we can write this square root 8 as square root 4 into 2, because 4 into 2 is equal to 8. Then we can write 18 as square root of 9 into 2. Similarly, square root of 32 is 16 into 2. Further, it implies it is square root of 2, then this is a 4, is a perfect square of a 2, then it will be equals to 2 square root 2. This is 9, square of a 3, we get 3 square root of 2. Here it is 16, we get 4 square root of 2. So this is now the square root 2 is first term here, then second term is 2 times square root 2, third term is 3 times square root 2, and fourth term is 4 square root 2. Now a2 minus a1 is equivalent to 2 times square root 2 minus square root 2 equals to square root of 2, because this is 2 times square root 2 minus 1 times square root 2 equals to square root of 2. Then a3 minus a2, a3 is 3 square root 2 minus a2 is 2 square root 2. So again by subtracting the 2 we get square root of 2. Then a4 minus a3 is equal to, fourth term is here 4 square root of 2 minus 3 square root of 2, that is also equal to square root 2. So here we observe that a2 minus a1 is equal to square root 2, a3 minus a2 is also square root 2, and a4 minus a3 is equal to square root 2. Therefore a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3. So when the common difference is same everywhere, then the given list of numbers is said to be an arithmetic progression. So when this given list of numbers is an arithmetic progression, then find next 3 more terms. Now we have to find out now a5. a5 is equal to a plus 4d, that equals to a, the value of a is equal to square root of 2 plus 4 into d, d is everywhere square root 2, so a5 is 4 times square root 2. Similarly a6 is equal to a plus 5d, that equals to square root of 2, the value of a here, and plus 5 square root 2, and a7 is equal to a plus 6d, that equals to square root of 2 plus 6 times square root of 2. So these are the next 3 more terms of the given arithmetic progression. Now we have another exercise, that is exercise number 5.2, which is based on the general term of an arithmetic progression, and we know that the general term of an arithmetic progression is denoted by an, and an is equal to a plus n minus 1 into d.